All right, guys. So we're back, continuing from where we left off from last class. Now we're looking at multiplication and division of algebraic quantities. Now in the previous class, online class, we looked at addition and subtraction of algebraic quantities. Now, from that class, we learn about terms and expressions. We learn about like terms. We also learn about unlike terms. And we saw that when we add like terms to give an expression, that expression can be simplified when we add or subtract like terms to a single term. However, when we add or subtract unlike terms, because unlike terms are actually not the same, then we are not allowed to add them in the usual way how we would add like terms. Now, to add like terms, we generally add the coefficient of the like terms. And when we talk about coefficient, we talk about the number that is attached to the unknown or the number that is attached to the variable. So for instance, if we have 3x, then the 3 there would be the coefficient of x. So the number that is in front of the unknown, we call them coefficient. Where there is no visible sign of a number in front of an unknown, we say that the unknown has a coefficient of 1, right? And the reason why we can use 1 as the coefficient, because whenever you multiply that unknown by 1, you get back the same unknown. So obviously, the coefficient is a number that you use to multiply the unknown. So if you have 3x, it means 3 times x. And if you have 1x, you get back x. So when x appears by itself without a number in front of it, then there's an invisible 1, so the coefficient would be 1. All right, so we would have gone through some exercises of adding and subtracting like terms, and we also saw where we have unlike terms, wherever we have a number of terms and we have some terms that are alike, we group them, we add their coefficients, we simplify that to a single term. Wherever we find that the coefficients are, the terms are not the same, then we leave them with the plus or minus sign between them in what we're adding. Now that entire thing become what we call an expression. So we saw that an expression really is the addition and subtraction of unlike terms. And because we can simplify them into a single term, we leave them as they are with the plus or minus sign between them. And the entire thing is known as an expression. All right? So that's what we looked at from the previous lesson. Now what we're going to be looking at is how to multiply and divide algebraic quantities. Now, when we say algebraic quantities, we are still referring to algebraic terms as a quantity. I remember when we talk about an unknown, we say that an unknown in maths can be a general statement. General to mean that that unknown, when we use a letter to represent some quantity, that letter can represent whatever quantity we choose the letter to represent. And so that unknown does not have a value until it is given a value. All right, so for instance, x, we don't know what the value of x is in an expression unless we assign a value to x, we would know what the value of x is, right? So in that sense, the unknowns, we're still working with the same unknowns when we're adding, subtracting, and also when we are multiplying and dividing. So today we are going to be looking at multiplication and division of these unknown quantities and algebraic quantities. Algebra suggests that we're working with unknowns. All right, so there are some rules. So the rules are exactly the same as those that were used in directed numbers, or what we refer to as integers. Now, what do we mean by the rules are the same? Can anybody give me an idea what I mean when we say that the rules are the same as used in directed numbers or integer? Ms. Wilson, would you like to help us with that?
No, sir, I'm not quite sure.
Okay. Mr. Campbell, would you like to help us?
I guess you probably work the same way as the other. I'm not sure.
Ms. Green, would you like to help us?
Good night, sir.
Good evening. Good evening, Shay.
No, sir.
All right. So what kind of rules do we use when we are dealing with directed numbers? Remember, directed numbers are the same as integers. And when we talk about integers, what kind of numbers are we talking about? Ms. Wilson?
Counting natural numbers, sir, including negative and positive numbers.
All right, so directed numbers are integers. We include positive and negative numbers as well as zero, all right? Now, what the rules that we're referring to would be the rules for adding, the rules for subtracting, the rules for multiplying, and the rules for dividing. Can anybody just orally tell me what the rules are when you're adding negative and positive? All right.
You're not referring to the laws, right, sir?
All right. This way, some are breaking up. So I'm not hearing you so well. I'll give you a chance to continue with what you're saying when I'm able to hear you well. All right, Miss Wilson. No, I'm not hearing you well yet. Not hearing you well, Miss Wilson. All right, I'm just going to ask someone else.
Sir, are you referring to the laws?
I'm hearing you now, Miss Wilson. Miss Wilson, are you there? All right, apparently Miss Wilson is not there. All right, is there anyone who would like to just quickly tell us the rule for adding and subtracting integers? Ms. Green, you want to help us with that? What are the rules? Ms. Green, I'm not hearing any response from you. All right, Mr. Ojeno, you know the rules for adding and subtracting integers? All right, Ms. Wade, are you there?
Yes, sir. Are you hearing me now?
Yeah, loud and clear. So would you like to through the rules for adding and subtracting integers for us?
I'd like to try, sir. Is it the same as when you add the number and you keep the sign of the bigger number.
All right, so yeah.
Add them both.
Yeah, we're talking about rules. So the rules would be, first one is what? When you're adding two positive, what you get?
Positive.
When you're adding two negatives, what you get?
Negative.
All right, so you want to continue for us?
Sure, sure. So negative plus negative gives you negative. And as I said before, sir, if you're adding a negative and a positive value, you would keep the sign of the bigger number.
All
so
right.
it can be either negative or
Negative
positive
plus
in that
positive.
case.
What is the rule?
You add them together, then keep the sign of the bigger number.
Yeah, add them together, then keep the sign of the bigger number. Sure, that's the rule.
No, sir, like you have minus 5 plus 3. So you know you add them together and you keep it. Then you get 2 and you keep the sign of the bigger number, which is 5, that had the negative sign.
All right. So when you say add them to number, add them together, what exactly are you saying?
I'm not sure.
Anybody else want to add something to this? Can anybody else say what happened for these two last rules? So we have 1, 2, 3, 4 rules here that we would have learned when we're adding negative and positive number. Give me a second, guys. Sorry about that, guys. All right, so Miss Wisdom, if you have a positive, if you're adding a positive and a negative number, what you generally do as a rule?
Sir, I just say like add them together and keep the sign of the bigger number.
How do you go about adding positive and negative?
So it all depends on which one is the which sign, which number carry, which of the sign carry the biggest number. So with the example I gave before, for example, you have a minus 5 plus 3. So you know the minus 5 would have been the larger number. Then you take 3 from that, so the positive 3 from that, leaving negative 2.
All right. I understand what you're saying in terms of the procedure. What I'm not getting from you, though, is the rules.
Okay.
You get what I'm saying, miss?
Yes, sir.
All right. So
Not sure how to express it, though.
All right, so if you have a positive and a negative number, when you're adding them, the rule is you first find the difference of the numbers. How do we find the difference of the numbers? You take away the smaller one from the larger one. So that's the first. So the rule for adding positive and negative, when you're adding a positive with a negative, take the smaller one from the larger one and keep the sign of the larger one in front of the difference. That's a general rule. Does that sound familiar to you, Ms. Wilson?
Yes, sir.
Right. So that is what we do when we're adding positive and negative. We would have gone through all of these already. I'm just recapping the rule for you to realize that we are still using the same rules when we are dealing with algebraic quantities. The same rule that we use when we are dealing with directed number, meaning that we will be seeing positive and negative algebraic quantities, and we treat them in the same way that we treat them when we are dealing with positive and negative numbers. All right, so for these, the rule would be find the difference. So you find the difference here. So find the difference. And then you do what? Keep the sign of the larger number. Can you give me an example of that, Ms. Wilson?
Yes, sir. I can use the same one I was giving you earlier. You have a -5.
So if you have -5
+3.
plus 3.
Okay. That will equal to -2.
All right. I want you to walk me through the process. I don't want to just show the answer at me. What is it that you do?
First, we find the difference of both numbers, which is 5 and 3. The difference, which means take away. So we take 3 from 5.
You take away the smaller one from the larger one. So the difference here is what?
2, sir.
2.
Yes, sir. And we keep the sign of the larger number
in front, the difference. So
yes, sir.
It becomes -2. The sign of the larger number is 5. The sign is negative, so that the difference take the same sign, and that becomes the answer. All right. So that's a general rule for addition. These are the rules that you follow when you're doing addition, right? Now, the rules for division and multiplication would be what? Anybody? So if I change these signs to multiplication, what would happen? How would this affect the rules? So positive times positive give you what in terms of sign?
Positive, sir.
Positive, right. Positive, negative times negative give you?
Positive.
Positive, right. Negative times positive give you?
Negative.
Negative. Positive times negative?
Positive.
Still
no,
negative.
Negative, sir.
Once you're multiplying two numbers and they have different sign, one is positive, one is negative, the answer will always be negative. Now, here is a little, what we call a caveat to the negative. If you're multiplying two negatives, you're going to get a positive. But suppose you're multiplying 3 negative. Would you get a positive just the same?
No, sir.
What will happen in that case?
You're going to get a negative, sir. Because one negative time negative would have given you the positive, and then the positive times the negative would then turn it back into negative.
So negative times negative times negative give you what?
Negative, sir.
Negative. Suppose we now have negative times negative times negative times negative. What we get now? What's the sign?
Negative, sir.
Positive, sir.
It's
Positive.
Negative, sir.
right.
Negative, positive.
Now,
Oh, yeah, positive, yes.
now what you notice with the two set of numbers here, how many negative in the first one? This one about.
3, sir.
This one. How many negative?
3.
3. How many you have down here?
4.
All right. How many you have over here?
2.
2. When you have 2 negative, the result is positive. When you have 3, it is negative. When you have 4, it is positive. So when you have 5, what you're going to get?
Negative.
When you have, what you're going to get?
6, I said, sir?
Yeah, if you have 6 negative.
Positive.
All right, so that is the general rule there when you're dealing with negative.
So when we have odd amount of negative, we get negative, sir.
Right. And when you say odd amount, what we mean by odd amount?
Number when divided by 2 has 1 as its remainder.
I'm not asking about odd number, Miss Witt. I need to be able to say explicitly what I'm asking you. When we say odd amount, what it means?
Not equal, sir.
No, odd amount meaning that when you count them, you get an odd number. So if you count 1, 2, 3, negative, 3 is a what?
Odd number.
Right. You count 2, 3, 4 down here. 4 is a what? Odd or even number?
Even.
Right. So the rule is if you are multiplying negatives and you are multiplying an odd amount, the result going to be
Negative, sir.
negative. And if you're multiplying negative and you're multiplying an even amount, the result will always be
Positive.
all right. So bear those in mind. Those rules, you have to recall them. All right, everybody is clear with what is happening here now. Any question before I move on? All right, one of my concerns for my students is that I can tell that a lot of you are not reviewing, a lot of you are not reading before you come to the class. So what that means, you come to the class without any kind of preparation. That means you don't have anything in your mind in relation to what we're going to teach, and it makes it a little bit more difficult for you to follow when you do that. So my advice to you is please spend at least half an hour, read something on the topic before you come to the class. All the topics that we're dealing with, they're already posted on the website. So you know where we are in the topic. So you can just read ahead before you come to the next class. Please do that and you will find it most benefiting. All right. So we're based on what we have just noticed, those are the rules when we are multiplying and adding. The same rule that works for multiplying also works for dividing. Multiplying 2, dividing 2 positive, you get back positive. And dividing 2 negative, you get positive. Dividing a negative by a positive, you get negative, right? So those rules, you have to apply them when you're working with algebraic quantity is just the same. All right? Now, when multiplying expression containing the